When faced with an EDTA titration problem, the first thing you should do is calculate that conditional formation constant. So we're given our alpha and we are told our Kf. So we're going to multiply those two values together. So 5.6 times 10 to the negative third times 3.2 times 10 to the 16th. And our conditional formation constant is then 1.792 times 10 to the 14th. Now we need to find our equivalence volume, and that way we can determine which side of equivalence we're on. So we have a 25 milliliter sample of 0.100 moles of zinc per liter of zinc, and we're going to be titrating that with EDTA. So 1 mole of zinc will react with 1 mole of EDTA. And we have a concentration then of 0.100 moles of EDTA per liter of EDTA. So our equivalence volume is then going to be 25 milliliters. So before the equivalence point, we have one set of rules, then at the equivalence point, then after the equivalence point. So knowing that, we are aiming for the PZN. So we're aiming for the negative log of the concentration of the zinc. Before the equivalence point, it is dependent on how much zinc is there. So at no milliliters of EDTA, before any EDTA is added, all we need to do is take the concentration of zinc. So the PZN is going to be equal to the negative log log of the concentration of the zinc. Before any EDTA is added, then we need to take what we're finding is the log log of 0.1, and that is going to be -1. When we have 10 milliliters of EDTA that is added, we have then neutralized, as it were. If you think of this as an acid-base reaction, we've used up 10 milliliters because they're the same concentration. We've used up 10 milliliters of our zinc. So we have an excess of 15 milliliters. If you want to think of it that way, you go right ahead. I'm going to calculate it the longer way, however, for those of you who might need that. So if I start with this many moles of zinc, so I'm going to multiply my volume by my concentration. Then I'm starting with 0.0025 moles of zinc. Now I've added 10 milliliters of EDTA. The EDTA has a concentration of 0.100 moles per liter. And again, we are working EDTA now. So I have added 0.00100 moles of EDTA. They react 1 to 1. So I'm taking away the amount of moles of EDTA. I'm taking that many moles of zinc away. And I'm left with 0.00150 moles of zinc are left after the reaction. So I need to use those moles and my total volume at this point to find out my concentration. So the concentration of zinc at this point now, I have 0.00150 moles of zinc and a total volume of 25 plus 10 or 35 milliliters. Convert that to liters. And there's a concentration of zinc of 0.0428, and then I have a 5.7. It keeps going, but I'm going to leave this in my calculator. So I take the log of this value, or the negative log of this value. So the PZN at this point is it's not negative. It's a positive 1.36, and then I have an 8. And I think I had a negative here. It needed to be a positive. So before any EDTA is added, the PZN is 1. When 10 milliliters of EDTA are added, the PZN is 1.36. I'm going to round that to 1.37. So now at the equivalence point. At the equivalence point, we have more calculations to do. So at the equivalence point, which we had learned initially that this was going to be our equivalence volume. At the equivalence point, what we have is an equilibrium. So we have our zinc is reacting with EDTA. It's going to be in equilibrium with our zinc complex. Now, the concentration of the zinc complex, if we take all of our EDTA in zinc and make all of it into the complex, then we have to find out how many moles we have. So basically the reaction was 0.0025 moles of zinc have reacted with 0.0025 moles of EDTA, and we're going to form 0.0025 moles of our complex. Okay, they're going to react completely and form this many moles. But what is the concentration? When we're working with K values, we need concentration in molarity. So we have this many moles. We need to divide that by the total volume. The total volume is 0.050 liters. So our concentration of complex is then 0.0500 capital M molar. Now we can work our equilibrium. Remember, when we have a Kf, that is a formation constant. We are forming that complex. So we need the ions on the reactant side and we need the complex on the product side. We have this amount or this concentration of complex, but we need to shift our equilibrium. We will shift it by some value x that we don't know. We're going to use our conditional formation constant that we also calculated initially, so that 1.792 times 10 to the 14th is going to be equal to the concentration of my product, which is 0.0500 minus x, over the product of our reactants, product being multiplication at this point, not chemical product. So x times x, which is x squared. Now we look to see if we can simplify this, and we can. Mercifully, we can. And so now it is just algebra. So when we work this out, multiply both sides by x squared to remove it from the denominator, then get that x squared by dividing both sides by this 1.792 times 10 to the 14th, we get that x squared is equal to 2.79, and it continues. I'm going to leave that in my calculator, times 10 to the negative 16. So we need the square root of that value in order to find out what our x is. So x is 1.67 times 10 to the negative 8. So now we need to analyze. What does x represent? Well, x represents the concentration of the zinc at this point. So we need to find the PZN. So in my calculator, I'm just going to hit log of that value. So the negative log of that value is the PZN. So PZN then is 7.7777. So I'll round that to 7.78. Now at 50 milliliters of EDTA solution, we also have some calculating to do. So we're going to change a couple of things here, but it's going to be a very similar calculation. So now, rather than just having this complex, now we have an excess of EDTA. So we still have our 0.00250 moles of complex that were made because we've used up all of the zinc that we had, the 25 milliliters of zinc. But now we have an excess EDTA. We also have a different volume. So we need to take the moles of our complex, divide it by the total volume now, which is 75 milliliters. So I have a new concentration of 0.0333, and that repeats. Okay, so that is the new molarity of this complex. My excess EDTA, I have 25 milliliters of excess. So I have an excess of 0.00250 moles of EDTA in excess. And dividing that by my total volume, it's the same concentration with the threes that cancel. But this time, when I shift my equilibrium, I have my 0.0333 here minus x. I don't have x squared under here. I have x times 0.0333 plus x. Now I can still simplify this equilibrium. This time I can also cancel these out. So I'm left with 1 over x equals this stuff. So when I take the reciprocal then, x is equal to 5.58 times 10 to the negative 15 capital M molar. The x represents the concentration of the zinc. So I take the log of that value and I find, and then the negative of that, so that the PZN at this point with an excess of 25 milliliters of EDTA, I have a PZN of 14.3 or 14.25.